Alright, so let's go to the next question. This is the next question. At temperature 300 Kelvin, the thermal energy kBT in centimeter inverse is approx. Okay, so this is the next question. Now we have discussed, right, basically 5-6 questions on statistical. We have already discussed, right, 10 questions in one special class, so you can watch that special class also. And we are going to discuss now 2-3 questions more, which will definitely help you to build your concepts in statistical. All right, so let's go with the next question. So this is the next question. So the question is, at temperature 300 Kelvin, the thermal energy kBT in centimeter inverse is approx. Alright, so let's try and approach this question. So see how we're going to approach this question. At temperature 300 Kelvin, the thermal energy kBT in centimeter inverse. Okay, so we need to find out thermal energy, and it's also given in the question that kBT represents your thermal energy. Now how I can say that this is your energy, let's try and find out through the units. Okay, kb is actually your Boltzmann constant. Okay, so what are the units of Boltzmann constant? First case is the units of Boltzmann constant is joule per Kelvin. Okay, and the unit of temperature is Kelvin. So Kelvin inverse and Kelvin will be cancelled out. Now you will be left with joule. Okay, and we know joule is energy unit, so definitely kBT is your energy expression. There is one more way to find out the units of kBT when we are using energy in centimeter inverse, right? Okay, so now in case of centimeter inverse, this is kb and temperature. Okay, so kb is centimeter inverse per Kelvin. Okay, and this temperature is Kelvin. Okay, so this and this will be cancelled out, so you'll be getting centimeter inverse. Okay, centimeter inverse, this is also energy expression. Now how I can say that centimeter inverse is also an energy expression, because we know E is equals to h nu. Okay, E is equals to h nu, so if I'll be dividing E with h, we'll be getting nu, right? If I'll be dividing E by h, we'll be getting nu. And how I can write down nu? C by lambda. Okay, so this E by h is equals to C by lambda. Now I have to get the centimeter inverse, so I have to take this C over here. So it's going to be E by hc is equals to 1 by lambda. Okay, so the units of 1 by lambda is centimeter inverse. Okay, E by hc is your basically, see, we are using joule. Okay, then we are dividing it by joule second, then we are dividing it by centimeter per second. So you can see now this is actually centimeter inverse. Okay, so we are dividing energy with a constant value, so definitely it's not going to affect your right, the essence of your energy. So definitely we can say that E, right, the units are joule, and we can write down energy in centimeter inverse. Okay, so this is how we can solve this particular question. Okay, now let's try and approach that what all information has been given to us in the question. Okay, we need to find out kBT, that means the thermal energy, in centimeter inverse. So I'll be using kBT value in centimeter inverse, that is 0.69, right, centimeter inverse Kelvin inverse. Okay, temperature is given 300 kelvins, right? Okay, so let's take this value approximately 0.7, because I can see there are actually very different values over here, so I can use this 0.7. centimeter inverse Kelvin inverse into 300 Kelvin. Okay, 0.7 into 3, 7 3s are 21. Okay, so it's going to be 2100 with one decimal place. So around, right, I can say approx it's going to be 2110 centimeter inverse, and there is only one option in the given series, right? So we can select it is 200, right? It's basically 200 centimeter inverse. So the thermal energy is 200 centimeter inverse. Okay, clear everybody? Any doubts in this question? So the correct answer for this question is going to be 200 centimeter inverse. Okay, now let's go to the next question. So just find out theta V of H2 divided by theta V of D2. Alright, so how I can solve this question? This is based on theta V. What is actually theta V? Theta V is vibrational vibrational temperature. Okay, this is actually your theta V, characteristic vibrational temperature. Okay, so now what is actually characteristic vibrational temperature? It is that temperature when your kBT, that is your thermal energy, is equals to h nu. Now the question is why I am taking kBT is equals to h nu, right? See, this comes from your simple harmonic oscillator. We know that we have levels, we have vibrational levels, okay? This is n value is equals to 0, vibrational quantum number, n value is equals to 1, n value is equals to 2, and n value is equals to 3. Okay, so we know that in simple harmonic oscillator, the energy expression is n plus half h nu, right? N plus half h nu. So this is actually with 0 point energy, right? Over here I'll be writing without 0 point energy, without 0 point energy. Okay, n0, n1, n2, n3. Over here I can write down n0, n1, n2, n3, n0, n1, n2, n3. Alright, okay. So next thing is if I'll be using n value over 0, so the energy is going to be half h nu. Right, over here the energy is going to be 3 by 2 h nu. Over here the energy is going to be 5 by 2 h nu. Right, and over here the energy is going to be 7 by 2 h nu. Right, now what can I see over here? That the energy difference is h nu, and h nu. Right, over here also the energy difference is h nu. How? If I'll be using n value is equals to 0 without 0 point energy, this means I'm subtracting minus half h nu from here, so it is going to be 0 energy h nu, 2 h nu, 3 h nu. Okay, so this difference is also h nu, this difference is also h nu, this difference is also h nu. Okay, so what can I write down? That energy expression, right? Energy expression of your SHO with 0 point energy is equals to n plus half h nu, right? And energy expression of SHO without 0 point energy is equals to nh nu. This is nh nu. Okay, right. So this is how I can find out the 0 point energy over here. Now next expression is what I need to do in the question. I need to find out the characteristic vibrational temperature. So characteristic vibrational temperature is the temperature at which kBT, that is your thermal energy, is equals to h nu. Why we are taking h nu? Because we know that this energy difference is h nu over here. This energy difference is h nu over here. So if I have to make transition of molecules in the ground state or in the lower state, right? So definitely I need to give some external energy. So that external energy should be equal to h nu. Then only we can expect transitions to happen. Okay, so definitely this value should be of near to your h nu value. Okay, so characteristic vibrational temperature is the temperature at which kBT is equals to h nu. Great, so this is why, that is why we are using this expression over here. Okay, now let's find out this value. kBT is equals to h nu. This means this temperature, that is your theta v, this should be h nu by kb. This should be h nu by kb, right? This should be h nu by kb. Now I know what is actually your mu. Mu is your frequency. Mu is your vibrational frequency, right? Mu is your vibrational frequency. So what is the expression of mu? That is vibrational frequency. Mu is equals to 1 by 2 pi k by reduced mass. This is how we can write down the vibrational frequency expression, 1 by 2 pi under root of k by mu. Okay, where k is your force constant, right, and mu is your reduced mass. How I can write down mu? Mu is equals to m1 m2 divided by m1 plus m2. This is how I can write down the reduced mass. Okay, so what I can observe over here, that this frequency is inversely proportional to under root of reduced mass. Keeping this k, that is force constant throughout your system analysis, this particular frequency is inversely proportional to, right, 1 by mu. Okay, 1 by mu. So I hope this point is very much clear. So now what can I write down? That theta vibrational is h mu by kb, and mu is inversely proportional to under root of mu. Okay, so can I say that theta is going to be inversely proportional to under root of mu? Can I say this thing? Theta is going to be inversely proportional to under root of mu. Definitely that is correct, because we know mu is inversely proportional to root of reduced mass. So theta v, which is also proportional to frequency, it's going to be inversely proportional to root of your reduced mass. Okay, so I'll be using this relation over here, right? This is actually theta v, right, inversely proportional to under root of mu. Okay, so now what we have to find out in the question, theta h2 divided by theta d2. This is what we need to find out. So what can I write down? Mu of d2, reduced mass of d2, and reduced mass of h2, right? You should be joining in the previous session, right, or from the starting Abhira. We have already discussed concepts in the plus course. You can join in the plus course, or we have already discussed this concept in one special class. You can cover from those special class. Okay, this is a continuation class, so under root of this expression. Okay, mu of d2, mu of h2. But if in case you are getting any doubt, you just let me know. I'll just cover that concept. Okay, mu is equals to d2, mu is equals to h2. So now what is the reduced mass of d2? m1 into m2 divided by m1 plus m2, right? So d2 is 2, 2 into 2 divided by 2 plus 2, that is 1. Okay, mu of h2 is equals to m1 m2 divided by m1 plus m2. M is equals to, m value over here is, this is 1, 1 into 1, 1 plus 1, that is 1 by 2. So what I'll be doing, I'll be keeping this mass over here, 1 by 2 divided by 1 under root. So it's going to be under root 1 by 2. So theta h2 divided by theta d2 is equals to 1 by under root 2, or I can say the ratio of theta vibrational temperature of h2 to ratio of theta vibrational temperature of d2 is equals to 1 by under root 2. This is how we can find out this particular question. Okay, I hope this is very much clear to all of you. Great. Okay, in case any doubts in the question, feel free to let me know in the comment section. Okay, now let's take one more question. So the question is the characteristic vibrational constant, vibrational temperature, that is theta V, of H2. This is what you need to find out, okay? Provided that frequency of H2 is 4401 centimeter inverse. So this is what you need to find out. You need to find out theta V when your frequency of H2 is actually 4401 centimeter inverse. आशीष, if अगर आपने जैम का प्रिपरेशन नहीं किया तो डीयू में like the thing is nothing is impossible, but at the same time if I'll be giving you practical answer. If your basics are very much clear, if your concepts are clear from entire chemistry, just you need to brush up the concepts or you need to cover the advanced things, then definitely it is possible. You have 1.5 months or 2 months, it is possible for you to get good rank in Delhi University. But if in case your basics are not clear and you have to start from absolute basics, so right, to be very honest, you need time, okay? At least you need 6 months to cover your basics and the advanced. But if in case your basics are good, you know each and every concept, right, from absolute basic, you need to cover advanced thing, so it is definitely possible. Okay, so let's try out and solve this question. Again, the question is on theta V. Theta V is equals to, right, h nu by kBt. Just now only we did this part. Theta V is equals to h nu by kBt. Okay, so if theta V is equals to h nu by kBt, so how we can proceed with this question? Theta V is equals to h nu by kBt. All right, okay, kb. So this is the theta v value, this is h nu by kb value. Okay, so I know this thing very clearly that they have given us the frequency in centimeter inverse. Okay, so I have to put all values in centimeter inverse. Okay, so how I'll be just substituting the values in centimeter inverse? If I have to convert frequency in second inverse to frequency in centimeter inverse, so what I usually have to do, if I have to convert second inverse in centimeter inverse, so I have to divide this with, quickly tell me what I have to do. I have to divide this with, right, actually I have to divide this with C, right, then only I can convert second inverse to centimeter inverse. So if I'll be dividing this value with H, why I'm dividing this value with H? See, pay attention, this is H nu. Okay, if I'm using this frequency value in centimeter inverse, okay, I know that this theta V is a temperature value, so I have to get Kelvin out of this expression. I have to get Kelvin out of this expression. Okay, so let's suppose I have h nu by kb. Okay, so if I'll be putting value of nu in centimeter inverse, nu in centimeter inverse divided by kb value in centimeter inverse second inverse. Okay, so I'll be getting this value of second inverse, that is I'll be getting the value of time in Kelvin inverse. Okay, so this is how actually I'll be getting the value of temperature in Kelvin inverse. Okay, this is Kelvin inverse. So I have to divide this overall equation with H. I have to divide this overall equation with H. Okay, because I'll be having this joule second which is extra. So h nu by kb divided by h, this h and h will be cancelled out. This is going to be frequency in centimeter inverse divided by kb. Okay, now I'll just substitute the values over here because the value is given in centimeter inverse. So mu is 441 centimeter inverse according to the question, and kb value is 0.69 centimeter inverse Kelvin inverse. This is how I'll be writing the values. Now you can just solve this particular expression and you can get to the correct answer. Okay, just divide this value and just tell me what value you are getting. So this value is approximately 6378 kelvins. Okay, so this is how you'll be solving this particular question, and I hope this is very much clear to all of you. Okay, so I hope this question is very much clear. There is no doubt in the question. Okay, right. So yeah, okay, we'll be continuing this session very soon because right now I'm facing some internet fluctuations. So I think it's not the live is not coming right properly. So I'll just reschedule this session, or I'll just again come live for this session and we'll solve a lot of problems. Okay, or I'll be taking a class on special class very soon, right? And we'll see a lot of problems from statistical. Okay, do not forget to just follow, right, my profile on Unacademy Plus platform, right? This so you can get access to complete content, and in case you want to get notified with updated links, you can just go down in the description box. There is a Telegram channel over there. You can subscribe to that Telegram channel. Okay, and this is my referral code Srishti B Live 10 in case you want to prepare for IIT JAM on Unacademy Plus platform. So you can use my referral code while taking the subscription.